Hello guys, so today I'll be solving this problem which is make sum divisible by p. So the problem states that we have been given a positive integer nums and we have to remove the smallest subarray such that the sum of the remaining elements is divisible by p. Okay, so we have been given a nums array, so let's call it a1, a2 to an. Okay, and we have been given this argument p. Okay, what we need to do is we need to find a subarray, let's call it L to R, and this is the subarray sum, and when I'm removing with the overall sum of the array, let's call it n minus 1 I this. Okay, then whatever sum I'm getting, that should be divisible by p. Mod p, it should be 0. Cool. So this is the problem statement. Then what we need to do is after it may happen like there are multiple subarray, so we need to find the smallest subarray that will satisfy this condition, which basically means r minus l plus 1, which is the length of this subarray, it should be minimum. Okay, now if you look at this expression, okay, so from this can we have an idea what should be the sum of the subarray? No. Okay, but one thing we can get is what should be the modulus, like what should be the modulus of this subarray, or like the subarray sum when we take p, because if I expand this expression, so this will become 0 to n minus 1 a of I mod p minus summation from L to R, which is the subarray sum, mod p. Okay, they should be equal to 0. Okay, which basically means the subarray sum mod p should be equal to the overall sum of the subarray mod p. Okay, and this actually makes sense, right? If we want the overall sum of the subarray to be divisible by p, we just need to remove the remainder. Okay, so this becomes our required remainder. Okay, so now you can think that, so now we can change the problem statement something like we need to find the subarray, okay, whose like summation of element in that subarray mod p should be equal to our rem. Okay, and it should be smallest, or and let's say r minus l plus 1, which is the number of elements in that subarray, it should be minimum. Okay, so this is our new problem statement. Okay, so if we solve this, we will simply solve the problem. Cool. Now what should we do? How to efficiently find the subarray summations? Okay, so with that, like we can clearly think of prefix sum. Let's increase prefix sum. Okay, so cool. So yeah, we can think of prefix sum whenever we are interested in subarray summation, because this will give us like the subarray sum in constant time. Okay, similarly we can use prefix sum to calculate the subarray modulus in constant time, right? For sum and sum mod p, we can easily use prefix sum to get either sum or the sum mod p. Okay, now let's think how prefix sum operates. So let's say this is my elements a1, a2, okay, like that. Let's say there is some a of l is there, okay, and let's say there is some a of r is there, and let's say to this a of n. Okay, when I need to find the subarray sum, okay, between L to R, what I do is I get the prefix sum from 1 to L minus 1, okay, and I get the prefix sum from 1 to AR, and I simply, let's call it P of R, let's call it P of L minus 1, okay, and I simply subtract them. Okay, so P of R minus P of L minus 1, okay, if I take their difference, this will give me the summation of all the elements from a of L to a of R, right? Now if I need like this guy modulus, okay, like mod p should be equal to my rect mem, okay, so I can do something like this. So p of R minus p of L minus 1 whole mod p, it should be equal to my a of L R a of I mod p, and which should be equal to my required remainder. Okay, now let's expand this expression. Okay, so I can say p of R mod p minus p of L mod p, okay, it should be equal to my required remainder. Okay, now if you see this, okay, now we have a relation between our prefix sums, right? Okay, so now you can think of, if you are going from, let's say again a1 a2 a3, some ar is there, okay, some an, if I'm going from left to right, okay, I can easily get this value, right? Because for every element in from left to right, I'll be calculating the prefix r, okay, considering every element of r index, okay, then I can easily get this mod value, okay, and this thing I can easily get by taking the overall sum of the array and modding it by p, okay. Now this guy will be variable, right? So it may happen, okay, let's say when I'm at this index, I'm getting prefix of r mod p here, okay. Now I need to find a L minus 1, okay, such that this expression will satisfy, okay. So it may happen I have multiple choices for my L minus 1, okay, like multiple prefix sum on my left, okay, are satisfying this. Let's say there is a, oopsie, yeah, let's say there is a index a of there is an index a of I, okay, and let's say there is an index a of L, or let's say a of j, okay. Here I is less than j, okay, and they are less than r, okay. So it may happen p of r mod p, okay, or the prefix sum for this p of I mod p, okay, that is equal, that this thing is satisfying this expression, as well as p of j mod p, okay, is also satisfying this expression. It may happen, okay, there are maybe two prefixes which are satisfying. Which one should I choose? Okay, now I will look at the problem statement. So it is saying that I need to find the minimum subarray, right, which basically means my p of, or let's say my r minus L plus 1, it should be minimum, okay, which basically means I should always take the rightmost guy, okay, for my L, because when I'm iterating from left to right, okay, this guy is in my control, okay, and one is constant here. Now this guy is something I have to choose, okay. Now in order to minimize this, okay, so it's something like this guy is fixated for me now. Now if I increase this guy, okay, such that L is like less than R, okay, if I increase this guy, or if I choose the rightmost L value which is satisfying this expression, then overall this expression value will decrease, right? So yeah, that's the idea. So when you are going from left to right in the array and you are calculating the prefix mod values, if you store per prefix mod, okay, here by prefix mod I'm saying prefix of r mod p, okay, if I store the latest index, okay, that is giving me this value, okay, latest index, okay, then whenever I'm doing whenever I'm looking for a L, okay, which will satisfy this condition for my current R, I will always get the maximum L value, okay, and if that is giving my requirement, I can update my answer to the minimum, like then my answer will get the minimum subarray length. So yeah, that's the idea. So So per prefix mod, I'll be storing the latest index, which I need a map kind of a structure. So I'll be using maybe a HashMap. Okay, like map in C++. So yeah, that's the goal. So let's code it up in C++. Okay, so first I need to find the required remainder, right? So for that I'll be taking the sum of the whole array. Okay, but you can see like the numbers are varying between like 1 to 10 to the power 9, so it may happen my integer might overflow. So in that case I will only take the modulus of my summation. So what I'm saying is, so let's call it my required rem as rem. So I'll be iterating over all the elements in num. So I'll be updating rem as rem plus le and mod p. So this will automatically give me the overall modulus of my sum of elements in the array. Okay. Now, if rem is already equal to 0, which means the overall subarray sum is already a multiple of p. Okay. Then in that case, I don't need to remove any subarray, right? Because the question states that like possibly empty also, right? So in that case, I will simply return the length of the subarray as 0. Okay. Now, if the remainder is not equal to 0, then that means I have to remove a subarray, right? So for that, I will use this prefix approach. Okay. So first, let's create a map to store the prefix mod value with this and the current index that is giving that. So I'll be using a map. So I'll say int of int. Let's call it finder. Okay. Now I need a variable to capture my prefix mod when I'm going from left to right. So I'll say in this is my prefix. Okay. Now it may happen you need to remove uh, so you need to remove the whole array as itself. Okay, so in that case we need to return -1. Okay, but in order to consider like removing all the elements, so in prefix sum what happens? Okay, so when I have a2 up to an, okay, my prefix of n should give me the whole sum, right? So in order to get this like the prefix of n, I should create my prefix array in 1 base indexing. Okay, so that I will have a null index at this position, right? So yeah, I need this null index, which basically means I'm not considering any element. Okay, in that case my prefix sum will be 0. So I'll say finder of 0 is 0. Okay, now I will be iterating over all the elements. So here I'll be following 1 base indexing, so similar to what we do in prefix sum and i++. And yeah, I think I haven't captured n, so I will capture n here, which is nums of size. Okay, now I will be updating my answer. So I need to initialize my answer to some maximum value. Okay, such that because I will be minimizing or I will be finding the smallest subarray, so I need to initialize to a maximum value, and here I can simply initialize to n. Okay, because n is a possible answer, right? If you remove all the elements from this subarray, then that is divisible by p. Okay, but if if we are removing the whole array itself, it's not allowed. So in that case we need to return -1. So I can write here itself, so or I can say something like this: if my whatever thing I will be doing here, okay, so even after that answer is still remaining n, okay, then that means I'll be returning -1, otherwise I'll be returning answer. Okay, otherwise my answer will carry a subarray length. Cool. So first thing first, I'll be updating my prefix mod. So I'll say prefix mod for the current element, which is nums of i-1, mod p. Okay, so this will give me the current prefix mod. Now I need to get my required modulus value, or basically I mean what should be p of l-1 mod p. Okay, so if I look at this expression, okay, so here my prefix of L minus 1 mod P, okay, it should be equal to my current prefix mod, which is P of R mod P minus required rem or required remainder, right? Now it may happen we may get negative values, so in order to resolve that, we will do a plus P here and we will take a whole mod P, okay, so that the values will lie between 0 to P minus 1. So yeah, so I'll say I need to search for L minus 1, okay, whose prefix mod is my current prefix mod subtracted with the required remainder that I am searching for, okay, plus P, okay, mod P. Cool. Now I will search in my map whether I have gotten an index that contains my required mod, okay. So I'll check if my finder.count of require mod, okay, if I have some value for require mod, okay, if I found it, then I will update my answer to answer equal to minimum of ans subtracted with the current index minus whatever index this guy holds, which is finder of required mod, okay. So my answer will be updated, and finally I will be storing the latest index for my current prefix mod, so which is finder of pre equal to I, okay. And with that I think we are good. Check for test cases. Yep, all pass. Let's submit. Cool. We are at the right, like very right side of this curve, but yeah, I think maybe because of I'm using finder, maybe I will use unordered map, it will be faster, but the time complexity for unordered map searching, sometimes it may overshoot to linear, so I always prefer using map because it's built on BSTs. So yeah, okay, on that only, let's discuss about time complexity, okay. So if I look here, what I'm doing, so first I'm calculating the overall sum of the array, okay, or the sum mod P. So in that I'm touching every element once, so that means big O of n here, okay. Then I'm creating this data structure, then I'm iterating over all the elements here, and here I'm doing this count check, okay, which is like a search in my BST, which is a log n operation. That means for every element I'm doing this check, so that will give me a big O of, so the number of elements I'm having times, so the size of my finder, okay. Now let's discuss on the size, okay. What should be the size of my finder, okay. So you might say like, hey, you might be storing all the values for lying between 0 to P minus 1. It may happen, but if you see the length is varying between 10 to the power 1 to 10 to the power 5, right? Okay, so whatever be the P, okay, so if I have only 10 to the power 5 elements only, that will never overshoot to like 10 to the power 9, right? That means my finder size will be at max, or like it will be minimum of the number of elements I have and P. So this should be my size, okay. So if I write it properly, so this will be big O of this linear time complexity, but this will be overtaken by this complexity because this is higher, so I can say it will be n log minimum of the number of elements I have, otherwise P. So that's my time complexity. Similarly for space complexity, so finder is the guy where I'm using extra space, okay. Now its size is this thing only, so big O of minimum of n P. So yeah, this is my overall time complexity. Cool. Now let's switch to a different language because we have already submitted it and it got accepted. Let's switch to Golang. Cool. So here I will be doing the same stuff that I was doing for C++. So first I will create this rem, then I will iterate over all the elements to uh, get my required mod. So I'll say range of nums rem equal to same code le mod p. I'll say if rem is equal to 0, then I can simply return 0. So if my required module is 0, then I don't need to do all that subarray calculation. Okay. Otherwise, I need to create a map to capture the prefix mod and the latest index that giving me that prefix mod. So I will say make of map of, I will storing int and int. Okay. And yeah, then I'll be creating my answer variable. So I will initialize my answer to n, and before that I need n. So n will be len of nums. Okay. And yeah, I need to set my finder of 0 to 0, because as per this logic. Okay, cool. Then I need to iterate over all the elements, so I'll be saying I1 I less than equal to, so similarly what we do for prefix sum, I plus plus. Okay, first I will be updating my prefix, and for that I need to create that variable. So 0, I will say prefix equal to my current prefix mod plus the current element nums of I minus 1 mod p. Now yeah, now I need to find the required modulus, or the required subarray modulus, like subarray sum modulus that I need to find. So that will be rect mod equal to my current prefix minus my required remainder plus p and a mod p. Okay, then I'll be saying if I need to check whether this required mod is present as a key or not. Okay, so for that I will be checking if the key exists. So I will get the value and the condition whether it exists or not. So finder of rect mod, if it exists, then only update my answers. My answer will be minimum of ans and my current index minus whatever index this rect mod, so which is like L, or maybe I can say L. Okay, or maybe I think it's a better idea to use R. Okay, R, and let's say L, and let's say this. Okay, cool. And finally I'll be updating my current prefix mod with the latest index there, so that will be I or R here. Cool. And finally I will have a check. If answer is still n, then that basically means I need to remove all the elements, but the question is not allowing it, so that means I need to remove the I need to return -1. Then I'll be, otherwise I'll return ans. Let's check for test cases. Okay, yeah, rect mod is a new variable, so I'm creating it. Cool, all test case passed. Let's submit. Cool, we are good. Then let's go for Rust. Okay, cool. So first I'll be creating my remainder, so it will be a mutable variable. I'll initialize to 0, then I'll be taking the summation of all elements. So this, and I will saying rem plus le mod of p. Okay, then I will check if rem is equal to 0, that means the sum of all elements is already a multiple of p, so I will simply return 0. I don't need to remove any subarray. Otherwise I'll be doing that subarray sum. So I'll create a variable to capture my current prefixes, then I will be creating a hash map. So I'll use std collection HashMap. Then I'll be also comparing variables, so I need comp. Okay, and yeah, they're good. So then I'll be creating my hash map. So let's call it finder. I'll be storing I32, which is my prefix mods, with usize, which is the index of the which is the latest index that is giving me the current prefix mod. Okay, then I'll say hash map HashMap. Okay, since the compiler will use this, and it will create my HashMap with this data type. Then I will insert 0 and 0. Okay, so that it will help me to check whether I need to remove all elements or not. Okay, then I need to finally create my answer variable. So it's a mutable variable, and I will initialize to n. And for that, I need to create my n first. So let n. Okay, I don't need mutable. So nums len, and then I will iterate over all the index. I need the index also, so I will be enumerating over them. So I will say le in nums into iter enumerate. Cool. Then I'll be updating my prefix mod with pre plus le modding with p. Then I will find the required modulus, or the required L-1 mod, the prefix mod basically. So yeah, I'll say rec mod equal to my current prefix mod and whatever remainder I'm looking for plus p mod p. Okay, so I got my required mod. Then I will say if this required modulus is present in my hash map or not. So I'll say if I'm getting some value for maybe use r. Okay, so I'm iterating over this, and here I'll say L. If I'm finding some L in my finder.get of this required mod. Okay, if I'm getting some L, then I will update my answer to comp of mean of answer of r plus 1, because this is 0 base indexing, minus L that I'm getting. Cool. Then I'll be inserting the current prefix mod value. So this will be pre, and I'll be updating r plus 1. Okay, and yeah, after that I will be checking whether answer is equal to n. That means I need to remove all the elements, and which is not allowed by the question. I will be returning -1, and then finally I will return answer. Yeah, let's check. Insert 0 0. Oh yeah, why am I doing this? It's basically this. Let's check. Okay. Why I'm doing pair in C++? Okay, this should replace the current value. Oh yeah, and finally this should be as i32. Okay, because I'm initializing with 10 and n is usize, so the compiler thinks as answer should be always usize. It's taking time. Let's check. Okay, everything passed. Now let's submit. Cool, it worked. So we are good. So all three languages done, and this was the concept behind the question. Okay, simple prefix sum, and just have a hash map to store the prefix mod for to store the latest index that is giving you the prefix mod. That will help you to calculate which subarray to look at. So yeah, that was the idea, and I hope you learned something new. So if you find this video helpful, please do like the video, and please do subscribe the channel. So thanks, just stay tuned to watch more videos, and yeah, bye bye.